Okay, good morning everyone. How are we doing today? Thumbs up? Better than last week? We gotten used to daylight savings time now? Oh, I forgot to set out the apples. Very important to set out the apples, otherwise you don't pick them up. There we go. Okay. This is Jasper last night. Ew. That's gross. Okay. Yeah, this is Jasper last night laying on me while we were watching TV, and it was just very good light. And I like the way the fake bokeh, that's the effect where like stuff in the distance is blurred, that the fake version here like really highlighted like these little hairs on the ridge of his nose. And then it just looks like total garbage up here. Anyway, okay. Couple of event announcements from me for stuff after break. First one specific to our class. So after break, we're going to be starting the next unit, which is on expertise and the idea of trustworthy expertise. And one of our running examples is going to be an organization from the HIV/AIDS movement in the 80s and 90s called ACT UP. ACT UP is really interesting from the perspective of thinking about trustworthy expertise because it's a group of people, in some cases, who didn't even finish high school. So these are, HIV/AIDS patients and allies within the broader queer community, especially in New York, for this documentary in particular. So folks who really heavily marginalized in the time, often didn't even complete high school, taught themselves the virology and the immunology of HIV/AIDS, and actually changed, based on like technical scientific critiques they were able to make, they changed the way, for example, we do clinical trials for diseases. So a really, really interesting example. This is a particularly moving documentary of the emergence of HIV/AIDS and then what ACT UP did up through the mid-90s when we finally found an effective way to prevent HIV from causing AIDS. So to prevent the virus from causing the collapse of the immune system. Really fantastic moving documentary. I'm going to be running a screening of it the evening of Monday, March 31st. So that's the day we all come back from break. 5:30 to 7:30 p.m. in ACS 102C, which is the little movie theater in ACS. Attendance is not required for this. I realize it's the first day back from break. That's a little suboptimal, but it's the only day I could get the room. So attendance is not required, but I encourage you to come. It's a really, really fantastic documentary. I'm going to plug it again on Thursday, and then I already have an email queued up to send you all a reminder that Monday morning after break. The second thing coming up after break, I am very excited about this. This is something the philosophy department has been working on putting together since August. This is a panel discussion and open forum on AI and education. So a lot of the things that we've been talking about a little bit here and there, probably things that you've been talking about in a bunch of your other classes, about the impact that AI is having on your education, the impact that it's likely to have in the future on the workforce, all of these kinds of things. So the title of this event is called Does the Future Need Us? The Ethics of AI in Education. We have three panelists, Hannah Gunn, who's a professor in the philosophy department, Jeff Yoshimi, who's a professor, joint appointment in cognitive science and philosophy, and Rosemary Bongers, who's a professor in applied math and runs the data science and computing program there. These three panelists are going to share their very different perspectives on AI education, its workforce implications, and then we'll have about an hour where anyone can stand up and share their opinion. I'm very excited about this. I think this is going to be very, very cool. If you're interested in coming, encourage you to hit the QR code and just to give us a registration, because we have one of the big lecture halls reserved, but if this really blows up, we're going to need to move to the really big, like 300-person lecture hall. I'm hoping that happens because I really want this. I really want this to have good attendance. Yeah. So those are two events coming up the week after we come back from break, and again, you'll get reminders about these. Any questions about either event? Okay. And any questions, or anyone have events that they want to plug? No one ever wants to promote their club's events in class. Why is that?
I'm not in a club.
You're not in a club? Uh-huh.
SJP is Students for Justice in Palestine at UC Merced is holding a Palestinian dinner and cooking demo on Wednesday, April 9th from 5 to 7:30 p.m. It's going to be in the DC, and you'll get to learn a whole bunch of recipes that are specific to Palestine.
Cool. If you remind me, like I guess it would be like the 8th, or if you're having people like sign up for it in advance, maybe the Thursday before, we can incorporate that into the slides. Other folks in clubs that are doing cool things? Or is Sahana the only one in a club or organization? No one wants to answer. You're all Schrodinger's club members. Okay. Yeah, we need to get moving. We've got a lot of ground to cover today. Okay. So over the weekend, Polyphony emailed me based on some stuff that she had seen happening, meeting one-on-one with students, and then also in the discussion sections. So I wanted to take a couple minutes to go over sort of why premise conclusion form suddenly got so complicated. So back in Unit 1, premise conclusion form was just like, yeah, you look at the sentences and you figure out the order to write them in, and you're more or less done. But now here in Unit 2, we have like a lot more structure, a lot more going on. In particular, if we consider this simple example, this example of a simple statistical inductive argument. In a survey of UC Merced students, 72% of people who responded said that UC Merced is the friendliest UC campus. So 72% of UC students think UC Merced is the friendliest UC campus. It might be tempting, if we think just from the perspective of Unit 1, to put this into premise conclusion form using the orange version, where we just have those sentences, we make sure they're in the order with the conclusion at the bottom, and we number them. That was premise conclusion form in Unit 1. But now in Unit 2, we have this version over on the right in blue, where we have a premise saying the target population is UC students, premise identifying the sample, premise 3 says that the sample is representative of the population. This thing we're going to be talking about this week, premise 4, the key statistic, and then the conclusion. So, question to check in with your groups on first for a couple of minutes. Why in this unit are we working with the more complicated blue version rather than the much simpler orange version? Why did we make that move? So take a moment, think to yourself. If you've got an answer, talk with the folks at your table. come back together in 30 seconds. Okay, so what do you think? Why did we make the switch? Why do we use this much more complicated premise conclusion form? Elizabeth?
I think it makes pointing out the flaws in the claim way easier.
Mm-hmm.
If you just read the paragraph or just the premise conclusion form, you wouldn't be thinking about what the sample is or if it's even representative of the population.
Yeah, good. So like premises 1 and 2 really draw our attention explicitly to what exactly is the target population. And sometimes you'll encounter generalizations where like even the author is kind of confused about what their target population is. Same thing with premise 2 in the sample, right? Thinking carefully, making explicit what exactly these key elements are. I'm going to come back to the point about objection. That's a good one too. Other answers? Other kinds of answers folks gave? Maybe somebody at table 3? What were you talking about? Same thing? Okay. Anybody say anything really different? Okay. In particular, Polyphony said, there were questions about why we need premise 3. So I was riffing on Elizabeth's answer, which wasn't specifically focused on premises 1 and 2, but those are the ones I highlighted in my riff. What about premise 3? Why do we need premise 3? Ruby, was that a tentative hand or just adjusting your hair? Okay. Why do we need premise 3? Devin?
Because I think it's the core part of the premises that support the argument. Because if something is not representative of something, then it can't be used as support for an argument.
Yeah, I would tweak that slightly. All 4 of these premises are crucial. If we're missing one of these 4 premises, or if one of these 4 premises maybe is there, but actually isn't acceptable, then we lose support for the conclusion. So if we don't have premise 3, if the sample isn't representative, or we don't have the information we need to figure out whether it's representative, these premises, this argument, can't support the conclusion. Now, why is that? Why is representativeness so important? Yeah.
If the sample isn't representative of the population, you can't say anything about the population based on the sample.
Good, exactly. Premise 3 is the premise that says we can take what we see over here in the sample and make an inference to the whole population. Premise 3 is what lets us go from the sample to the population. If we don't have representativeness, then even if premise 4 is of really high quality, and we're going to be talking about that this week, even if premise 4 is really high quality, it doesn't tell us anything about the population. I can do a really good, careful survey of UC Merced students, get really good data on which campus you all think is the friendliest one in the UC system, but because you're not a representative sample of all UC students, That doesn't tell us anything about all UC students. Does that make sense? Are there questions there? Okay, so just to kind of reiterate the point here, the reason why we move from what we're doing in Unit 1, just looking at, okay, what elements does the author of the argument give us explicitly, to now in Unit 2, we're thinking more about what elements does the author need in order to support their conclusion. And that will often be beyond just what they say explicitly. So the argument in red is making a bunch of assumptions, for example, most crucially, that we have a representative sample, that is premise 3. And so in order to make that assumption explicit, in order to be able to assess it, and in order to be able to consider, does this argument actually support the conclusion, we work with the more explicit structured version in blue, rather than the simpler version in orange. Does that help clarify why we need all of these parts? Any lingering questions, confusions, or uncertainties here? Okay. So, recapping from last week, we're looking again at representativeness. What the hell is going on? Oh, that's super weird. What the hell? Okay, so the slides that you all are seeing don't match up with the slides on my laptop. Okay, sorry, this is super weird. Okay, we'll turn screen mirroring back on. That looks good. Okay, we are good now. Okay, so last week, talking about representativeness, the idea of representative samples, looking at the idea of plausible relevant variation as a way we could think about representativeness without getting into the math of taking statistics. We had 3 main examples last week: the Danish MMR study, which we're also going to look at today, vaccine hesitant YouTube comments, and a survey that you all took in class on whether or not we should have an express bus to downtown. Looking at those, thinking about plausible relevant variation, we finished up by talking very briefly about how we could take violations of Rule 2, where we don't have a representative sample, and present those as objections to premise 3, for example, in an argument map. Are there any other questions, confusions, or uncertainties left over from last week? Okay, so this week we're going to look at our third and final rule for this unit, which says that reliable statistics come from reliable processes. This rule is really focused on premise 4 of a statistical induction, which we call the key statistic. So the key statistic, for example, in the Danish MMR study, is the one that says only 1.7 per thousand children in the sample who received the MMR vaccine developed autism. And I'm sorry, the conclusion here, the conclusion 5 should be slightly different from this because we broke up, we broke up some steps anyways. Ignore that. The important part here is number 4. Only 1.7 per thousand children in the sample who received the MMR vaccine developed autism. So this is the key statistic. It's important to understand the key statistic is making a claim about the sample, not the population. So the conclusion is about the population. The key statistic, premise 4, is about the sample. As a first pass, and I think this is the way I explained it 2 weeks ago when we started with statistical induction. As a first pass, we can think of the key statistic as what we observe in the sample. So the researchers who conducted the study, they observed that only 1.7 per thousand children in the sample who received the MMR vaccine developed autism. This is a premise. This is sort of a starting point, what we observe in the sample. And in the conclusion, we want to draw an inference to something about the population. So the key statistic here, premise 4, is about the sample rather than the population. We can think of it as what gets observed. Questions about the vocabulary here? Okay. Now what we observe in a statistical induction is actually more complicated than just I look, around the room and count hands. If you think about what must have gone into actually tracking millions of children, I think it was millions. It was either millions on the order of hundreds of thousands. Millions of children, we'll say, over about 10 years, and looking to see, did they get the MMR vaccine? Were they diagnosed with autism or not? This was fairly complicated. A lot of people did a lot of work, a lot of steps along the way to produce this study, and not just the people who are credited as the authors of the study. So statistics have to be made. When we read a number like in the newspaper or on social media or wherever, those numbers don't just pop into existence. They are something that people have to make. And often, not always, but often, many people are involved who each do their own little contribution in different stages of the process and might not even realize that they're contributing to that. So you might think about like the pharmacist or the pediatrician who administers the vaccine is contributing to this process of generating the data that becomes the key statistic. But they don't see themselves as doing that. They want to protect this kid from measles, mumps, and rubella. So when we assess premise 4, we need to think about the data generating process. This is a term I'm borrowing from statistics. Statistics constructs mathematical models of this process. We are going to be thinking about this in terms of 4 steps or stages. I call them target specification, data generation, data collection, and data interpretation. And then at the end, we get the key statistic. So we have this 4-step process that lies behind the key statistic. And when we're asking, is the key statistic acceptable, we're asking, was this process, this 4-step process, was it really reliable in generating, collecting, and analyzing, and interpreting the data that we are seeing at the end? That was super abstract. So we're going to be walking through the data generating process for the Danish MMR study. So we'll use that to illustrate these 4 different phases of the data generating process. I wanted to put some quick links here in the slides. We are not going to have time in class to go through the really detailed analysis that I included in the online textbook. So that starts, not on this page, but on this page. So you can see I have a few paragraphs or more for each step of this process for the Danish MMR study, and then a summary down at the bottom. Okay? So I encourage you to read through this, especially with your study groups, and especially for like steps of this that you maybe don't fully understand or get confused about after today. I also have a link here to the original paper. It's what we call open access, meaning anyone can read the paper. It's all right here. a lot of it is technical, but the thing about scientific journal articles, depending on the field, is that often you can make some headway into understanding what's going on just with sort of general college level education. So you can take a look at this, and there are parts that you probably won't understand, but also parts where it's like, oh, I think I sort of know what's going on here. Okay, so you can also take a look at the original paper. If you're interested, I have sort of quotes from the relevant bits in the notes. And then the prose version from last week, just quoted here if we want to refer back to like what we actually saw, as it were. Okay, so these are just quick references. We're going to dive in to this 4-step model of the data generating process that leads up to our key statistic. So the first step is target specification. When researchers do a study, I have a note in the textbook about how there's actually no such thing as the scientific method. What you were taught up through high school as the scientific method is a lie. That is not how science actually works. You can read that note, and then you can take Introduction to Science, Technology, and Ethics from me in the fall if you want to learn more about why the scientific method does not exist. There is no such thing. But one thing we can say is that researchers generally start a research project with a more or less specific research question in mind. There are things that they care about, and there's some more or less well-defined question that they are trying to answer. This is target specification. They are specifying the target for their study that's going to produce the key statistic and so on. The target includes both the target population, that is X, the grammatical subject of the conclusion, the group or the class of things that we are making a claim about, and also what I'm calling the target property or the target predicate in the notes. This is why the grammatical predicate, the property of that population, and the research question can often be framed as something like, how many X's are Y? How many people who are exposed to the MMR vaccine develop autism? I kind of gave this away, but we can illustrate this with the Danish study. So looking at just this prose version, you should be able to roughly reconstruct the research question. What question were the researchers asking, trying to investigate? We've already talked about the population quite a bit. We haven't talked about the target property using that term, but I actually mentioned it like 90 seconds ago. So in groups, take a second. See if you can articulate the research question, the target population, and the target property. Okay, let's come back together. Research question, target population, target property. What were they trying to do in the Danish study? Oh, Ayush? Sorry.
They were asking how many kids who receive the MMR vaccine develop autism. The target population was kids in
That's the target population. Let's take another 30 seconds to think about this. We can look at the research question. We can look at the conclusion of the argument. It's got kids who receive the MMR vaccine, and it's got people who develop autism. Well, it's people who receive the MMR vaccine, people who develop autism, but kids, people. That's not an important difference here. Question is, which one is the population and which one is the property? Take 30 seconds, see if you can figure that one out. Which one is the population and which one is the property? Okay, let's come back together. Somebody at table 8. Which one's the target population? Which one's the target property? Genuinely unsure? Okay, anybody? Duncan?
My reasoning would be that the population is the people who receive the vaccine and what was the word you used? The property?
Yeah.
Was the people who develop autism. And the reason I think that is because the scientists who are doing this research can control the variable, which is whether or not somebody receives the MMR vaccine. That's the thing that they can observe a difference between. And they're trying to establish a connection to what is hypothesized to be a dependent condition.
Yeah, that is interesting reasoning. It is actually incorrect here. We're going to come back to that in a couple of slides, though. But it's good foreshadowing for a distinction I'm going to make in a couple of slides. Yeah, the target population, the group of people that the generalization is about, is people who receive the MMR vaccine. Target property, people who develop autism. Yeah, Devin?
Is the target property the link between a vaccine and autism?
So if we were talking about what's called causal inference here, yeah, the sort of direction of causation, or whether or not the MMR vaccine causes autism, like that's the question in the background, right? This question, this research question, how many kids who receive the MMR vaccine develop autism? This is a question about correlation. This question is not asking, does the MMR vaccine cause autism? This is asking, is the MMR vaccine correlated with autism? Causation is tricky. There used to be a unit on causal inference in this class, and I had to drop it because with everything else we didn't have time. It would need another 3-week unit, and we just don't have another 3 weeks in the semester. There's the aphorism that you've almost certainly encountered, correlation is not equal to causation. That aphorism is a little bit misleading because we care about correlation because it provides what's called defeasible evidence of causation. Defeasible means that something can be defeated. So correlation is like preliminary, partial, weak, incomplete evidence of causation. So if we saw that there was a significant correlation between the MMR vaccine and developed autism, that would be not a absolutely conclusive reason, but that would be like some reason, some evidence that the MMR vaccine would cause autism. So if we saw that correlation, that would be weak, partial, incomplete evidence that the vaccine causes autism. On the other hand, if we don't see a correlation, then that's evidence, and actually somewhat stronger evidence, that there isn't a causal relationship between them. These issues get tricky and get complicated, and you actually really need to think through, what is causation? How do we try to observe causation or study causation? What kinds of research do we need to do to track causation? This is why, like, it starts off as 3 weeks just to get a basic understanding, and I could probably do a whole course on just causal inference from both a philosophical and a statistical perspective. So we here are just talking about correlation. But we care about this correlation because of the background question of whether there's a causal relationship here. Questions or comments on that? Okay, so step one, the researchers specify their target. They're asking how many kids who receive the MMR vaccine develop autism. Their target population here is people who receive the vaccine, and the target property, people who develop autism. The difference here is this class is broader than the sample, is the way to think about it. We don't have we have a sample, a small set of people who receive the MMR vaccine, rather than everyone who receives the MMR vaccine. Okay, so for each of these phases, or steps in the data generating process, I've written out what I call critical questions. These are the things when we are assessing an argument we want to think about for this particular phase. So for the target specification phase, the critical questions are whether the target property is clearly specified or whether it's ambiguous or vague. What challenges are there to accurately measuring the target property? And will these challenges tend to lead to either undercounting, where we count fewer cases than there actually are, we miss some actual cases, or overcounting? There are more cases than we actually count. And so we end up overestimating. No. Undercounting means we underestimate the true number out in the world. Overcounting means we overestimate. We have more cases that we count than there actually are. Just think, you have a target on a vertical number line. If you go under, you have too few. If you go over, you have too many. So, for the Danish study, we want to ask these critical questions. Our target property, again, is having autism. Is that property clearly specified, or is it somehow ambiguous or vague? What challenges are there to accurately measuring autism? Will these challenges tend to lead to undercounting or overcounting? Are the questions clear enough? Okay, take a few minutes. Talk about those in your groups. Okay, let's come back together. For the sake of time, I can't give you all like a lot of time on each of these steps. but I'm hearing some good conversations. So, what do you think? This target property, clearly specified, ambiguous, difficult to measure, easy to measure, and do these difficulties tend to lead to undercounting or overcounting? What did you say in your groups? Duncan?
I feel like it is pretty clearly specified by the study. Like they're not
Okay.
particularly ambiguous about what they're testing for. It'd be kind of a weird scientific study if they were like, well, we're not really sure. We might have.
Oh, you should take my classes. It's a nice thought. It would be great if the world worked that way. Sahana.
I feel like testing for the target property of autism in this case is ambiguous because there's challenges like misdiagnosing or underdiagnosing because some groups are like less likely to be tested for autism than others. Like for example, girls might not be as diagnosed at the same rate as boys are. And also, not everyone has the resources to be properly tested for autism. And also, there's this thing called masking, in which people who are autistic may hide their symptoms in purposefully in an effort to appear not autistic.
Yeah. So, Dana's study challenges. There are both challenges to defining and measuring autism. By international committees, change over time. So one challenge with autism is that there isn't a physiological test. You can't draw a blood sample from someone and analyze that to determine whether or not they're autistic or are on the spectrum. Instead, they have to be diagnosed by a psychiatrist through an observation process. There are standards and definitions for this, which are set by international committees, and they develop over time as psychiatrists try to get a better understanding about autism. But there's a complex relationship here. Like, how do you tell if you have the right definition of autism if you don't have a good way to measure it? And how do you tell if you have a good way to measure it if the definition isn't really stable? So this is a real challenge that psychiatry has had to struggle with over the past century. This is not unique to psychiatry. Actually, every other scientific field has had this same sort of challenge where in order to develop good theory, we need good ways to measure the thing, but we don't have good ways to measure the thing unless we have good theory that describes how the thing works. It actually took a long time to develop reliable thermometers and reliable ways to determine your location on the Earth, like GPS coordinates. Those were both really hard problems that took like a few centuries of hard work to really figure out how to do those well. And something like autism is still in what we might think of as relatively early stages here. Yeah, Duncan?
So, what was said over there
Uh-huh.
brought up a question for me, which is, if I'm very specific about an ambiguous thing that I'm trying to measure, where does that fall? Because all of those things listed there I'm aware of, but I would have interpreted those as more of challenges to measuring it rather than being unspecific about what we're trying to measure. If I say I want to measure how many blades of grass there are in the big field that's on that side of campus, I've been very specific about what I want. The issue is, what do you count as a blade of grass? Like there's different plants and whatnot that are very similar to grasses and so on and so forth. So where does that fall under the definitions we've got of it?
Yeah. So the right way to think about this diagram is, quite a few of you are STEM majors. Some of you are not. Even as STEM majors, you may know basically nothing about like epidemiology. So the diagram, the steps here, are a heuristic, a framework that you can use, that I want you to use, to think about, well, where did this number come from? What were some of the challenges that must have happened in the background in order to get this number? So reading a little bit about the challenges, like how is autism diagnosed? Reading and thinking a little bit about that. Now, you want to consider that target specification versus data generation, or vice versa. That, like which particular bucket you put these concerns into, is less important to me. What's more important is that you're being thoughtful and you're using these steps as a framework and you're asking these kinds of questions. You're looking at, say, this study about autism, and you're thinking about, oh, I actually don't know how they measure autism. There's actually a really nice Wikipedia page on it, and sort of you go, you spend a little time reading that, you realize there are these challenges. Which bucket you want to put them in, I kind of leave up to you, but being thoughtful in this way is what I'm really going for. So on the argument assessments, for example, I will be asking you, I will be looking for, do you think through each of these 4 steps? Are you being thoughtful in each case? Are you taking a little time to dig in, sort of beyond what's going on just in the argument itself? That's what I'm looking for, and less, do you have this in exactly the right bucket as I understand it versus you understand it? Does that help, Duncan? What I care about is thoughtfulness and using the tools I'm giving you, using the tools we're developing, rather than exact definitions. Any other questions there? Okay, so the target specification step, there are some concerns about both defining and measuring autism here. For now, we'll just keep those sort of in the background. We'll put these steps together, hopefully in about 20 minutes, but we'll see how fast we get there. Okay, next step, data generation. And this relates to a point that Duncan wanted to make a few minutes ago, which is that in the Danish MMR study, the researchers could control who gets vaccinated or not. The researchers actually had no control over this. These researchers, if I remember correctly, don't play any role in Danish childhood vaccination policy, right? It's those public health officials who set the vaccine schedule, and it's like pediatricians working with parents who actually determine whether or not a kid gets a shot. So this is not an example of what we call experimental research. Experimental can mean a lot of different things. In this context, experimental just means the researcher can control the generation of data. You might think of an experiment as like there's a manipulation or an intervention or something like that. The way I'm using it here, it's the researcher can control the generation of data. So when I did the survey in class last week, that is experimental research according to this definition, because I, in the role of the researcher, could cause you all to generate data for me. So I was in control of the generation of data. The Danish MMR study used what we call, or I call, found or opportunistic data. These are data generated by someone else for completely different purposes. The Danish public health system did not generate these vaccine records in order for these researchers to analyze them for whether or not the MMR is correlated with autism. The Danish healthcare system generated these data to promote the health of residents of Denmark. The researchers sort of found these data, had an opportunity to use them to address this question about the relationship between the vaccine and autism. So this is found or opportunistic data. Yeah.
If somebody generates data and then you, separate from them, use it for the same thing, is that still experimental research or is that something else?
That falls into a nice gray area. Often, I will say, it's very rare for a scientist to generate some data, make it publicly available, and then another scientist picks it up and does the exact same thing with it. That's pretty uncommon. When I do empirical research with my social scientist hat on, I use a lot of found or opportunistic data. But sometimes that includes data that other scientists have generated, but for very different purposes. That kind of situation is more common when we're talking about public data. If you think of like a data scientist almost always working with found or opportunistic data, and it's, people on social media are not generating data for the data scientist to analyze so that they can like maximize ad click-throughs or whatever. That data, they don't even think of it as generating data. They're just like interacting with their friends in the glowing rectangle. Very different purpose from the researcher's purpose, and that's sort of the key difference here. Okay, I put these two questions on for discussion. I'm going to skip those for the sake of time. In the Danish MMR study, the researchers had to use found or opportunistic data, these public health records, or these medical records that they did not create themselves. Interesting question, which kind of data do you think is most common in science? I'm just going to leave that question hanging out there. You can think about it for fun if you like. Critical questions here. In this particular data generation, what measures or variables are supposed to correspond to the target property? How well do these actually correspond? And are there features in this particular data generation that tend to increase or decrease undercounting or overcounting? So again, the ultimate concern here is, are we tending to get too few or too many? So take a couple minutes, think about that. Think about the data generation. Kids getting shots and medical records being entered. This tend to lead to undercounting or overcounting. Okay, unfortunately for the sake of time, have to pull you all back. Sahana's excellent points, which they raised in the context of target specification, we could also put here, in line with Duncan's concern about like which box do we put things in. That can be kind of flexible. So we could put Sahana's concerns, like who has access to mental health care, who tends to be screened, the phenomenon of masking. These could go in this data generation box just as easily as in target specification. Were there other issues? Other thoughts here? Deb?
We talked about how, because the study was done like 30 years ago,
Mm-hmm.
roughly, that some of the practices they did would be less efficient or accurate today. And
Okay.
Since they're all Danish, they may have specific practices different than other psychiatrists.
Okay, yeah, like the issue of potential Danish-specific practices, this is an interesting one because it kind of bleeds across to representativeness, right? It doesn't necessarily mean that like the key statistic is inaccurate for the sample, right? It may be entirely accurate like within the Danish context, but thinking about this can make us think about, oh, like, do the Danes maybe use a different way of diagnosing autism or something like that? That's a good question. From what I could tell, not actually an issue here in particular. They note in the paper that they use like this international standard procedure at the time for diagnosing autism, but it's a good question. Other potential issues here? Some other things you might think about, since this was done 30 years ago, the records probably would have been primarily on paper. And so maybe there's a risk of like some records being lost or corrupted, although they did this like relatively recently, so maybe that's less of a risk now. Thinking about like the physical process is helpful here. Probably like the actual collection of medical records, unlikely to be like a major issue per se, right? You can get errors in your medical records, but usually like they get corrected relatively efficiently unless something's gone pretty wrong. Okay. Any other thoughts here for step 2? Okay. Step 3, data collection. That should be in this step. The researchers actually get their hands on the data. So this is the step where the patient records go from Denmark's public health record system, national healthcare record system, to the particular researchers, the like, I think it's 5 epidemiologists who actually did the study. When we're talking about experimental research, this may be trivial. So if you think about the survey, I collected the data at the exact same time that you all generated it. You generated it by raising your hands, and I counted data generation and collection, exact same process. If you think about more complex surveys where there's a survey platform like Qualtrics or SurveyMonkey that you fill it out, there's maybe a small gap there, but the survey platform is more or less being used to generate and collect the data at the same time. However, you can have kinds of what we think of what qualifies as experimental research by this definition that there is a gap between data generation and collection. This bit about large telescopes is probably more confusing than helpful. I'm going to focus on particle colliders. So particle colliders used by particle physicists are these big, giant facilities. It's very expensive, very complicated to run a single experiment. And so what happens is the facility sort of takes orders from physicists. What kind of experiment or what kinds of data do you want us to collect? And then they sort of design like big combined experiments where they can generate data for a bunch of different studies all at once. So here, the data generation is done by the staff and the equipment at the particle collider, and then it has to be sent over to the physicist who's actually going to analyze it. So that's one way in which we can get a gap between data generation and collection, even in experimental research. This really becomes non-trivial when we talk about found data. So for example, these epidemiologists have to access medical records, but it's important to protect the privacy of patients. So there might be a step in which the medical records have to be scrubbed and anonymized before the epidemiologist can see it. Another example from my own research, a project I've been working on for a couple of years, involves downloading and analyzing the text of about 33,000 journal articles. Downloading these while trying to comply with various publishers' intellectual property rules, which are often poorly explained, like they're not very well documented. And so like trying to download all these journal articles while also navigating all these really explained rules led to certain gaps. So for example, there's one journal that we were only able to get about 10% of the articles because the journal just didn't make the other 90% available in a format that we could use in the study. So these are where you can get gaps between the generation of data and the collection of data. Critical questions here: how did the researchers get access to the data? Were there restrictions or limitations that created additional challenges? And did these tend to increase or decrease undercounting or overcounting? So take a few minutes, think through potentially what this was like for someone working with medical data on kids getting vaccinated and whether or not they're autistic. Challenges here. Hello. Okay, come back together. I'll give you 30 more seconds. Nope. Okay. How did the researchers get access to the data? Any plausible restrictions or limitations that created additional challenges? Tend to increase or decrease undercounting or overcounting. And just like with plausible relevant variation, it's less about have you spent a couple of hours figuring out this variation, and the bar is a little bit lower. Is it plausible to be concerned about, are there plausible issues here which raise some concerns or that we would want to be thoughtful about or want to double check did the authors talk about in the paper? So what are your thoughts here? Duncan?
I would imagine one of the primary sources of potential issues would be because this is sensitive information, there's probably a fair number of people who sign some sort of opt-out form in order to restrict the usage of
Oh, interesting. Okay.
and that may result in undercounting because you don't have access to a portion of the gathered data.
Yeah, that's an interesting one. I did not think to look for that in the paper. Be an interesting question whether or not that's an issue that they raised. Or potentially, you know, it's a national healthcare system. You can't opt out of the national healthcare system. They might not have been able to opt out, which could raise maybe potentially some ethical issues, but those aren't the issues we're concerned about here. Shri, is that a question on your face? Okay. other issues here? Duncan?
I mean, it's probably substantially more minor, but you did already mention that there may have been data just simply lost to time over the window that the study was looking at, and that data being gone would also result in undercounting.
Okay. So the way to think about over and undercounting here is, are these relevant to whether or not someone develops autism? Or in other words, if someone has autism or is diagnosed with autism, is that more likely to make them opt out or more likely for their data to be lost? Yeah, Jack.
I think if there were, like, if they were different departments, kind of, for the, like, their vaccine information was stored and where, like, psychological information was stored,
Yeah.
then you might see, like, the autism diagnosis get lost more or less in vaccine.
Yeah, that's actually a really important one here is the need to link data sets. I don't think we have any data science majors, if I remember right. Like 90% of data science is cleaning data, and 90% of cleaning data is figuring out how to actually link these two data sets you've got. And so I did notice that there's I forget which paragraph, but one of these paragraphs goes into some detail about like how they did the linking across multiple data sets. So that is definitely a crucial one. Okay. 3 minutes left. So I think we will do this last step and then kind of a recap to summarize next time. So, fourth step is data interpretation. This includes the things you cover in a stats class, like calculating means, medians, regression models, hypothesis tests. If you're familiar with these methods and you look into how they're actually used in the argument you're analyzing, feel free to, use those in your assessments. If you're not familiar with these things, that is okay. I am not expecting you all to have taken stats. The data interpretation step also includes things like how numerical outputs and measures are interpreted. So, for example, we get this number. So the researchers get their hands on maybe anonymized vaccine and autism records. They run through a script. The script outputs a number, 0.00107, which is equivalent to 0.07 per thousand, but there's an interpretive step. 1.07 what per thousand what. Those two things need to be filled in to interpret the numerical output. Kind of similarly, there's a potential gap between diagnoses of autism and cases of autism, which we kind of talked about already in terms of measurement. And then under the step, we also want to think about how the key statistic traveled from the researcher to you. So for example, they wrote a research paper, which maybe went into a press release that a journalist wrote up into a news story, and then somebody made a TikTok video about it, which is how you actually heard about it. It's important to think about the various steps that the statistic might have taken as it got from the researchers to you, and how interpretation might have modified things along the way. If you think of the game Telephone, the point of the game Telephone is that as a message travels, it can has to get reinterpreted. It can become kind of garbled. Same thing can happen, especially if you're looking at something like a social media video. There can be a big chain, there can be a long chain of people between what you see in the social media video and what was actually going on in the research paper. Okay, that is probably time. That is time. This step is not a big deal here because the prose version we've been analyzing is my summary of the abstract of the article. So data interpretation, not a big deal here except for stuff we've already talked about, like the gap between diagnoses and cases. So we will go ahead and finish this here. Next time, we'll kind of synthesize these points, refresh ourselves with these points, synthesize them together into an overall summary. And then we're going to be looking at the second case study, which is a bit of political advertising and a survey behind it. Any quick 30-second questions for today? Very good. And go ahead and finish your 2-sentence papers. Have a great rest of your Tuesday and great Wednesday, and we'll see you on Thursday.